In the previous video, we took a look at visualizing the confusion matrix and then extracting the performance report. In this video, we're going to evaluate cars based on their characteristics. Let's see how we can apply classification techniques to a real-world problem. We'll use a dataset that contains some details about cars, such as the number of doors, boot space, maintenance costs, and so on. Our goal is to determine the quality of the car. For the purposes of classification, the quality can take four values: unacceptable, acceptable, good, and very good. You can download the dataset at archive.ics.uci.edu. You need to treat each value in the dataset as a string. So let's go to the car.py file. We consider 6 attributes in the dataset. So here are the attributes along with the possible values they can take. First is buying. These will be VHI, high, med, and low. The second is maint. These will be VHI, high, med, and low. Next is doors. These will be 2, 3, 4, 5, and more. Then we have persons. These will be 2, 4, more. Then comes lug boot. These will be small, mid, and big. And the last one is safety. These will be low, mid, and high. So given that each line contains strings, we need to assume that all the features are strings and design a classifier. In the previous chapter, we used random forests to build a regressor. In this video, we will use random forests as a classifier. So let's see how you can do this. We'll use the car.py file that we already imported to you as a reference. Let's go ahead and import a couple of packages. These are the packages you need to import. Let's load the dataset. Each line contains a comma-separated list of words. Therefore, we pass the input file, split each line, and then append the list to the main data. We ignore the last character on each line because it's a new line character. The Python packages only work with numerical data, so we need to transform these attributes into something that the packages will understand. In the previous section, we discussed label encoding. That's what we use here to convert strings to numbers. So these are the lines of code we have used to convert strings into numbers. Each attribute can take a limited number of values. We can use the label encoder to transform them into numbers. We need to use different label encoders for each attribute. For example, the lug boot attribute can take 3 distinct values, and we need a label encoder that knows how to encode this attribute. The last value on each line is the class, so we assign it to the y variable. Now let's train the classifier. So you can play around with the n estimators and max depth parameters to see how they affect the classification accuracy. We will actually do this soon in a standardized way. Now let's perform cross-validation. Once we train the classifier, we need to see how it performs. We use threefold cross-validation to calculate the accuracy here. One of the main goals of building a classifier is to use it on isolated and unknown data instances. Let's use a single data point and see how we can use this classifier to categorize it. So you can see here we have done it by using this code. Here the first step was to convert that data into numerical data. We need to use the label encoders that we used during training because we want it to be consistent. If there are unknown values in the input data point, the label decoder will complain because it doesn't know how to handle that data. For example, if you change the first value in the list from VHI to ABCD, then the label encoder won't work because it doesn't know how to interpret this string. This acts like an error check to see if the input data point is valid. So now we're ready to predict the output class for this data point. Here is the code for predicting the output and print the output class. Finally, let us run this code. So you can see the output class now, which is UNACC. Now let's go to the editor again. We use the predict method to estimate the output class. If we output the encoded output label, it wouldn't mean anything to us. Therefore, we use the inverse_transform method to convert this label back to its original form and print out the output class. In this video, we have evaluated cars based on their characteristic using the classifier. In the next video, we'll extract validation curves.